This is the YIAV Schema, a cognitive architecture which builds a machine from bidirectional binary facts. There are a half dozen or so white papers about it at various stages of details at braingears.blogspot.com. braingears.blogspot.com. This presentation motivates the primary concepts of the architecture. Everything the being knows about the world is represented as a binary fact in a fractal mechanism. The fractals exist interconnected in a directed acyclic graph network. All communications uses bidirectional variables, which have information flowing up and down the DAG. They afford a natural expression of knowledge, especially when it's used in sparse representations. The YIAV schema functions with a stable inner loop dynamics, which are Bayesian-like. A few example configurations of YIAV elements will illustrate its functionality. A 4-fractal example of a Necker cube pops as humans do. We will show YIAV can incrementally invert perceptual causality using a configuration called a turtle, a hierarchically configured associative memory. A second bidirectional variable can be added to every link to hold the current simulation point as the being's thought progresses. Super Mario Brothers will start learning by finding out which way is up and continue until it finds the princess. Learning involves just adding new elements to the DAG. All unknown sensations must be explained by adding additional associations to the hierarchy. Unexplained fractals, those with the biggest estimation minus desire signals, are preferred. Full learning of such new associative memories may take multiple episodes to complete. Statistics are kept to aid in volume processing of the DAG. And based on better subsumptive understandings. For each fractal the being knows about in the world, it has a fractal to represent that knowledge in the being. Facts are binary predicates, true or false depending on the state of the world. They're PDFs. A few examples are shown. Here we ignore how attention shifts can change this map. Fractals communicate with bidirectional variables made from two unidirectional scalar variables, an estimate and a desire. Estimates reflects that the fact is true in the world. Desires encode three things: a prediction that the fact should be true or become true. This validates that the fact is properly known. A desire that the fact should become true per the being's utility function. This is a key part of action planning. That one fact subsumes another. This is key in building sparse decoders. According to David Marr, there are root causes in the world which dominate others. A process called perceptual causality determines the senses at the being from them. For instance, I attend AGI, so I go to Oxford and I present the ideas, and in so doing, I say words. The result is sound waves that reach your ears. The purpose of the YIAV schema is to invert this perceptual causality by creating a semantic network in a DAG, a simple network of associative memory elements. The metric of the DAG is called sophistication. Each link, shown in black, contains an estimate up and down, and a desire down. A factory continually adds YIAV elements to the network driven by experience. This is a preliminary simulation of a DAG with YIAV elements. New patterns of evidence enter at the bottom. They flash when they change. Unique causes exist at the top of a V element. Link colors are idle links with estimate and desire both 0 are white. Links with only estimates and no desires are green. Link with both desires and estimates are black, and links with only desires are red. Next, we show two A-nodes operating together, an AND node making a distinction, and an OR node signifying equivalences. The familiar case involves estimates flowing upward. We estimate it's raining, and we estimate we have an umbrella, and thus we will stay dry. A more powerful case involves both up and down operations. We imagine that it's estimating, that we imagine that it's raining, and we desire to stay dry. This produces a desire to have an umbrella, either umbrella A or B. Note that if it's not raining, the desire for an umbrella goes away. A-nodes connect several workers to one boss. They have several forms, including AND, an associative memory element used to encode coincidences, and an OR, which encodes equivalent elements, equivalent fractals, for instance, a face in various rotations. A-nodes combine estimates upward from several workers to one boss. A-nodes distribute desire from one boss to its multiple workers. The function omega determines the distribution and is normalized so the desire is conserved. Omega reflects deficit, the most needed to complete the AND, or it reflects incumbency with an OR. Other functions besides AND and OR are also possible. I elements are links. In their simplest form, they merely relay estimates up and desires down. Estimates can be multiplied by a constant to increase their importance. Desires can be multiplied to increase the drive for them. Downward desires, D+, can be reflected back to estimates, E+. This is a kind of optimism. It means that I imagine I have what I want. Similarly, downward bottom estimates can be reflected back to desires, D-. This is a kind of peacefulness in that I imagine I want what I have. By setting K1 and 2 to 0 and K3 and 4 to 1, the machine operates in two independent zones. Variables are defined as an array of fractals, for instance, red, orange, and brown. When variables are normalized, the result is like a probability. Pre-emphasis of fractals using a gamma or power law gives greater emphasis to the largest, and hence the term winner takes most. At the top is often a mirror function, as we talked about earlier. For example, consider Brown's estimate being twice orange's. A squared law gives Brown 4 times the estimate of orange. Normalized, it gets 80% of the desire. Consider a Necker cube where the vertex A appears to be in front, or perhaps vertex B. Shown in more detail, the overlapping segments A and B being presented indicates A is near, while the C and D indicates B is near. We show a YIAV schema which generates A and B near. It pops between the two just as humans do. It operates as follows. In case 1, all line segments are true except D, which is 0. A near dominates the winner take most, given the large value of K2. The desire down to B is greater than that of D. The mirroring at K3 causes desires to make an estimate even greater. In case 2, next evidence D becomes true. Now all inputs are the same, but the interpretation stays at A near because of the mirroring at K3. This is an example of how the schema holds short-term memory. Finally, case 3, evidence D declines from 1 to 0. At some point, B near overtakes A near and the winner takes most, and the schema flips. Humans experience a similar kind of understanding popping. It is also what happens at the punchline of a joke with a more complex semantic network. Here we show a turtle unit that is attached to two variables. The first is a door, which might be opened or closed, and the second is a driver, which might be me, nobody, or someone else. A set of AND A-nodes records all the coincidences observed. All 6 possible combinations form the state space. Predictions of which state will follow are shown with a red arrow. They are implemented by adding to normal links a second variable about what will happen next. A prediction element is then an AND A-node that associates the now variable of 1 to the next variable of a second. Of course, turtles can have many different models. Perhaps the drivers can change without the door being opened, which model takes charge is determined by the winner take most box. A car also has a key and a motor. Here we have simply added turtles between all pairs. The leftmost turtle is the one we've seen before. At each sequence, a sequence in time is shown from the idle car to driving away. Each turtle enforces a perspective based on the information it knows. Together they form a much larger model. We are proposing this way of cascading will work for many, perhaps dozens of models. These could be part of an evolutionary computing environment. Note how a desire to be driving away might initiate the first step, opening the door. This shows an elaborate environment to develop and tune the detailed operation of fractals. Lower left is the SuperTux, a shareware clone of Super Mario Bros. There are 7 joystick fractals. There are 475 screen icons, as shown on the right. Note a 25 fractal fovea is shown in the box on red. It's connected to the evidence variables of the turtle. On top, this slide shows infrastructure only, not fully functional fractals. Again, the details of the architecture are at the website braingears.blogspot.com. I'm Alan King, and I invite your emails to understand or enhance. Thank you for your interest and your attention.